Hey everybody, welcome to another common support video. This one's going to be on converting multi-digit repeating decimals to fractions. So here's the assignment. Just click on that and it will load up hopefully in here and we can start to see what we're working with. Perfect. That's repeating decimals to fractions. I don't want that one. I want multi-digit. So let's go change that. Learner home. Assignments. Okay, converting multi-digit. There we go. That's what I want. All right, let's wait for it. See if it loads in like it's supposed to. All right. Seems like it's loading in there. Here we go. Okay, so this one's converting multi-digit repeating decimals to fractions. Yeah, that's the one I wanted. Perfect. Okay, so let's go on and take a look at how that could play out. So this one's actually a really easy one. It's the same as the first one we did, just one of those ones that you know the pattern for. So let me just kind of do that one quickly. So number one, it's just going to be, let's zoom in so we can see a little better here. You guys can all see a little better. 0.7 repeating. So 0.7 repeating. You ask yourself, what place value does it repeat in? The 10th place. So that means the numerator is going to be 9. Or sorry, the numerator is going to be the repeating element, and the denominator is going to be 9. So you're going to have 7 over 9, right? And if you want to know why that's the case algebraically, it's just because you'd say let x equal 0.7 repeating. And then we can multiply that by 10 to get rid of this repeating element, because if we multiply by 10, we can isolate that repeating element and remove it. So watch. So we go, okay, let's say 10x then would be equal to 7.7 repeating. And now we can say a statement that 10x minus 1x, which is really worth or equivalent to 7.7 repeating minus 0.7 repeating. So that would be 9x is equal to, this 0.7 repeatings are going to cancel out, and you're going to be left with just 7, right? And then you want to solve the equation by undoing times by 9, so you divide both sides of your equation by 9, hence why we get 7 ninths. Now, that's where the answer comes from, right? So this is the justification of why this pattern works. But the shortcut is that if you have a repeating decimal in the tens place, then you're going to put it over 9, and the repeating element becomes the numerator. If it was in the hundreds place, you put it over 99, which is 1 less than 100. So basically, because you're always taking away this 1x, right, the denominator is going to be 1 less than the place value. So if it's in the tens place, 1 less than 10, 9. If it was in the hundreds place, 1 less than 100, 99, and so on and so forth. Anyways, that's a little refresher. Now let's get into the next problem. This one's pretty easy. So 7 ninths. 7/9. There we go. Okay, this one's harder. Okay, this is a harder problem. So this problem number 2, there's a couple ways that you can do it. So the first way is going to be, I'll do my way, okay? And then I'll let you guys see the con way as well. All right, the algebraic way. So if you're doing it my way, what I would do is I like to just kind of use what I already know, the patterns I already know, okay? So what I would do here is I would say that, let's zoom in, make it even clearer for us to see. So when I'm doing this problem, what I would do is I'd say there's a fixed element here that I can easily understand, 2.2, right? That stuff doesn't have any repeating elements to it. So then I would identify that and say that that's going to be 2.2. So let's make a little darker green value there. So that's 2.2. So we know that this is value of 2.2. Let's do the darker green. 2.2. Okay. So that's just like darker green element that you see right there. It's fixed. Okay. We're going to add to that, whatever this other part of the decimal is, which happens to be 0. Let's do that in a different color. Let's do that in a darker blue too, so it shows up. Let's do a darker blue. There we go. So let's add to that 0.067 with the 6, 7 repeating. So 0.067 with just the 6, 7 repeating. Okay? Now, if you add those two things together, you're going to get 2.267 repeating, with just the 6, 7 repeating. Now I can think about it as these two values, right? So this is 2, that's just 2. we're going to have this as 2/10, so that's really 2/10. It's like 2 and 2/10. And then we're going to add to that this blue thing. How do I write this blue thing as a fraction? That's the tricky part, right? It's not that tricky because I know how to write this. I can think about how to write this repeating element as a fraction. That's easy. Remember, what places it end in? The hundredths. So it would be over 99. So I know that 0.67 repeating is just going to be equal to 67 over 99. That's not that scary. That's pretty comfortable. And then all I have to do is figure out, well, how can I move the place value such that this thing becomes this thing? So how can the pink thing become the blue thing? What adjustment needs to be made, right? Well, if you think about the adjustment, right, what's actually happening here is you're just moving the decimal from where it is here in the pink thing, 1 to the left. Well, what does that mean? It means that you're going to have to take this and divide it by 10. If you divide this by 10, you're going to get this thing over here on the left in blue. Right? So ultimately, that tells me that I can write this as a fraction pretty simply. I just go 67 over 99, which is the repeating element, right? And then I just take that and I divide it by 10, which is the same as multiplying by 1/10, right? Dividing numbers is easy as pi. Just flip the second and multiply. So ultimately, this becomes worth 67 over 990. Now, if I were to test that out, you guys would see that 67 divided by 990 is, in fact, that 0.0676767 forever. So watch, you'll see what I mean. See? 0.0676767. So now that I understand what that blue value is as a fraction and what the green value is as a fraction, I can just put it all together, right? So what's this going to be worth? This is going to be worth the 2. And 10 times what would equal 990? So 10 times 99, right? So we're going to do 2 times 99, which is the same as 2 times 100, take away one set of 2's. So we're looking at 198, right? So what we end up is 198 over 990. And we're going to have to add to that. Let's add a black in here. Let's change the bright yellow to black because we don't want black, bright yellow anyways. And so we're going to add to that this 67 over 990. And you're going to get your answer, which is going to be equal to 2 and 198 plus 67. Now 198 plus 2 gets to 200. So if we take 2 away from 67, we have 65. So really what we're looking at is 2 and 265 over 990. Okay, fair enough. Now 2 and 265 over 990 can be simplified. But before we do that, let's just check to make sure it works, right? So is 265 divided by 990 equivalent to what we hope it would be equivalent to, which is going to be 0.267676767. 0.2676767. Okay, we did it. It's a good job. And now we're going to simplify this. Now, what can I divide top and bottom by? Well, one ends in 5, one ends in 0, so I think we can divide both by 5 for sure. So that would be 2 and how many times does 5 go into 265? So you could do a little 265 divided by 5 thing here. And 5 goes into 26 5 times with 1 left over. 5 into 15 goes 3, so that looks like it's going to be 53. And then the 990 divided by 5, what would that be? So 5 into 9 is 1 with 4 left over. 5 into 49 is going to be 9 with 4 left over. And then 5 into 40 is going to be 8. So that's going to be 198. And let's just double check to make sure we didn't make any mistake there. So 53 divided by 198 should be the same thing it was before. And it is. So we're feeling pretty good about that. And I'd say that's your final answer. Okay. So what is the answer here? You would write 2 and 53 over 198. Okay. Now that's my method. That's how I like to do it. But there's also the Kahn method and how Kahn likes to do it. So let me show you that alternate option right now. So it was a 2.267 with a 6-7 repeating. So here's the algebraic method, right? So the algebraic method that Con did in his video is going to look like this. It's going to be 2.267, the 6, 7 repeating. We don't need to worry about that 2. So you can think of that as just 2. And so all we really need to pay attention to is the 0.267, right? The 6, 7 repeating. So we can set this as x. So we can say, all right, this is equal to x. Now, if this is equal to x, we want to get rid of this repeating value that's in the hundredths place, right? Because it's two places that are repeating, so 10 and then 100. So it's an order of 10 to the second, right? So what you're going to do is you're going to say, all right, then what would 100x be equal to? So if this is 1x, then 100x would be just move it 2 to the right. So that means that 26.767 repeating is going to be equal to 100x, right? And then what Con would have you do is Con would have you say, all right, then 100x take away 1x is going to be equal to the 26.76. We had a little moment there, but I think we're back. So let's see if the computer can handle all this stuff I'm doing. So 26.767, and then bar there. And we're subtracting from that 0.267 with a bar over it. Okay? And so this over here becomes 99x. Oh, that's easy enough. But over here, what happens? So what you get there is you get 26.767 repeating, and you're subtracting from that 0.267 repeating. The 6, 7 repeatings are going to cancel out, so that goes to 0, right? They're going to go away. And you have 7 take away 2, which is 5, and then bring down your decimal, and then 26 take away nothing, which is 26. So ultimately, what you end up with there is 26.5 as the value on the right-hand side. Then you want to undo times by 99, so you divide by 99 both sides, and you get your answer, which is going to be x is equal to 26.5 over 99. You multiply top and bottom by 10, and you get that very same 265 over 990. And then you'd have to simplify from there. So the answer is the same, right? This is the process Con would go through, and then the process that I would use is over here. So it really doesn't matter which way you do it, as long as you're careful. You're going to get the same answer, right? So you would then add the 2 back in after you're doing the Con method, and you'd say the answer was 2 and 265 over 990, and then you'd have to simplify that, which is eventually going to be the same as what we inputted, 53 over 198. Okay, let's do the next problem. Now that I've done it both ways, I'm going to do it my way for some of them. I'll do it Con's way for some of them, so you guys get a variety. Okay. So the next problem is 3.48 repeating. Okay, so this is number 3, I believe. So let's do this one. This is number 3, and it is going to be 3.48 repeating. This one is really easy. This is one of those ones you're like, yes, score. The 3 just stays the 3, right? So all we got to do is write the 48 hundredths repeating. Right? Where does it end? What's the place value it ends in? It ends in the hundredths place. The shortcut I taught you guys was that if the repeating element ends in the hundredths place, you put it over 1 less than 100 or 99. So that means you're going to get this over 99. And then the numerator is just going to be the repeating element itself. So the numerator is just going to be 48. So this is just 33 and 48 over 99. Now, what's 4 plus 8? 12. What's 9 plus 9? 18. So both of those are multiples of 3. So we're going to get a simpler form of this that we can divide both by 3 and get that. So let's do that. So we're going to get 3, and 48 divided by 3 is going to be 16. And 99 divided by 3 is going to be 33. So the final answer you'd have here is going to be 3 and 16 33. So that's what you write. 3 space 16 slash 33. And that's how you do that one. Okay. And then the last question they have here is going to be one that I can do in multiple ways. This is a number 4. Let me do this. There we go, number 4 here. And this is 3.53, so 3.53 with just the 3 repeating. So I'm going to do this Mr. Fishback's way, and I'm going to do it Con's way, or algebraically. And then we can see which way you like better. Either way, it doesn't matter. So let's do it Mr. Fishback's way first. I would ask myself, okay, what's my fixed element there? My fixed element is 3.5. So that means that I know that this is the same as 3.5 plus my repeating element, and my repeating element in this case is that 0.03 repeating, so 0.03 repeating. I would then say, all right, let's figure out how to write this repeating element. That's the tricky part. So what do we do with that? We think about something we know that we can write that's similar to it. So we can think about, in this case, 0.3 repeating. I think we all know how to write that. That's just going to be 3 over 9. Okay, cool. Well, what are you going to do to get this pink thing to become this blue thing? Looks like you've got to move the decimal 1 to the left. So we got to shift this decimal 1 to the left, which means we're going to divide that by 10. And then we're just going to times this by 1/10, right? So that means ultimately that for this problem, we can figure out that the blue value is going to be really 3/9 and then times 1/10. So it's really going to be worth 3/90, okay, or 1/30. And so you can have this value as 1/30. Cool. We're going to add to that 3 and 5/10, which is the same as 3 and how many 30ths? That's the same as 3 and times top and bottom by 3, you get 15/30ths. And so now we can combine all of our bits. We can say, all right, so this is really going to be 3 and 15/30ths. And we're going to add to that the 1/30th that we know is the blue part. And so that means our final answer is going to be 3 and 16/30ths. Divide top and bottom by 2, and you can see that that's going to be 3 and 8/15ths. And see if it works, right? Is it going to work? Let's find out. So here's a calculator, and it always can check it by a calculator. 8 divided by 15 should work to be 0.533333. There you go, perfect, which means that this is going to work out just fine. So the correct answer would be 3 and space 8/15. Okay, 8/15. There we go. And that's my method, right? Then there's the con method you could use as well. So if I was to use the con method, let me add a page here. The con method for this problem, in case you guys were curious how it would work out algebraically, is going to be basically to say, all right, I've got this 3.53 with the 3 repeating, and I want to first, I don't need to worry about the 3, right? So con would basically say, okay, you don't need to worry about the 3, so that's going to be 3 plus some fractional value. So what he's going to have you analyze is 0.53 repeating. And say you'd set that as x, let x equal 0.53 repeating. Because there's only one place that's repeating, we would do 10. So we're going to times it by 10. So that means that you're going to move this to the right one. So that means we're going to get 5.33 repeating, which is because you have the 5.3 repeating, right? But that means the 3 is going to go on forever. So it's probably 3 repeating. And that's going to be equal to 10x, right? And then you just set up an equation, right? So you get 10x minus 1x is equal to 5.33 repeating minus 0.53 repeating. And then this is going to become 9x's is equal to whatever this is worth. Now, over here, we can think about what that's worth. That's 5.33 repeating, and we're subtracting from that 0.53 repeating. The 3 repeatings go away. You can't do 3 take away 5, so you borrow. That becomes 4. Write that out nicely for you. 13 take away 5 is 8. So you're going to get 4.8 there, right? So it's going to be 4.8 as your value over here, and a 9 over here. So then we're going to undo times by 9, divide by 9 both sides, and we're going to get x is equal to 4.8 over 9, which is the same as 48 over 90, which is the same as divide top and bottom by 3. You're going to get 16 over 30, which is the same as 8 over 15. And notice that's the same thing we came up with before, right? So this would be the algebraic method. So this is like kind of the con algebraic method that you could use to get the value. And we know that we got to add back in, of course, the the 3 that we kind of siphoned off in the beginning, right? Remember that 3 we siphoned off? Yeah. So we got to add that 3 back in. So we take this value here, we add that in. So it's really going to be 3 plus 8/15. Hence, therefore, the answer being 3 and 8/15, right? So this is the algebraic method, right? So this is the algebraic way to do it. And then there is the Mr. Fishback's way, where I like to just kind of use what we already know, the shortcuts we already know. So this would be Mr. Fishback's way. And both ways work, okay? So hopefully you guys are comfortable with that, and there you go.